So let's. I'm just going to organise this to-do list a little bit. Turn that down just a little. Okay. So on Tuesday. That's weird. I thought we marked a bunch of these as done. Oh, okay, never mind. Anyway, on Tuesday we did finish recording. Oh no, we didn't. Sorry. That was Tuesday. We managed to build a render pass. So we've got all of these things in to do still. What are we going to do today? Let's hopefully finish recording this render pass. But also I want to get this validation layer in. So Vulkan provides validation layers. So I think a validation layer should give us some insight as to what's going on here. So basically what happened was we run our executable and it's going to pop up a window, and the idea was to just try and get into a presentation loop with Vulkan, but for some reason we only managed to present twice and then we get this VK timeout, so which is not necessarily unexpected, but I didn't entirely anticipate that happening this quickly. So let's see if the validation layer shines any light into that. I think that's probably what I'm going to look at first. Maybe we'll try and get that command buffer in as well. Yeah, we'll leave it at that. So let's move that over there. And get back to work. So, validation layer then, how do we do that? Oops. Put that out of the way, there we go. Back to the Vulkan tutorial. VK Luna G standard validation is the name of the layer. So I believe layers are when you create the Vulkan instance. So we've got needed extensions. Yeah, we're not really doing anything with that. We haven't got any layers at all, so. So we had to turn this string into a char star C-style array of characters, and then we're also going to turn that into an array. Not strictly necessary, but let's do it for clarity. Actually, an array, a pointer to an array is the same as a pointer to the very first element, which is exactly what the str pointer is anyway. Layers pointer. So enabled layer names. Oh, I don't actually need to find that tool. Just put it like that. That is not enough to actually get any information out of this validation layer, of course. But I'm just curious that. Ooh, wow! We've got all sorts of information already. I did not expect that to happen. Surface is not known at this time to be supported for presentation by this device. Yep, that is an error as well. That's pretty cool. So I didn't actually think that it would be that easy to get validation enabled, because you usually have to set a bunch of callbacks in of how it actually prints stuff out, but I guess this Intel driver probably just does it. Cool. Acquire next image. Semaphore and fence cannot both be null. So this is what I was thinking anyway. So it's good that the validation layer has pointed this out. There will be no way to determine the completion of this operation, which is the problem we're having. Images passed to present must be in layout VK image layout present source KHR. Don't know what that is, but it looks like we've got a bunch of stuff here. Cool, well, that was easy. We've got a validation layer in, and it is giving us some things to look at. So, let's recap from what we had last week, or the last stream even. We've got all of this device setup stuff done. We load the extensions, we create the instance, we create a physical device, we find the queue family, we create a logical device, we get the surface, we create a swap chain, get the images from the swap chain, create frame buffers, and I thought we were all ready to actually do some rendering at that point. So we wrote this tiny little loop here, which tries to acquire an image from the swap chain, and then tries to present that image immediately after. Now, the problem is, acquiring an image from the swap chain and presenting it are both inherently asynchronous operations, as almost everything is in Vulkan. And I thought that these operations would at least be asynchronously dispatched from the same queue with a kind of first in, first out semantics, but that's not the case. So it seems what happens is this acquire next image could actually be executed by the GPU at some random time, which has no bearing on when present is called either. But what we actually want, because this is doing double buffering, is to pull an image out and then wait for that image to be pulled out before we present it. And I guess, yeah, so those two operations have to be sequenced one after the other. And Vulkan gives us a way to do this, the Vulkan API gives us a way to do this with semaphores, which essentially means acquire next image is going to write to a semaphore when it's complete, and we can have present block on a semaphore so it doesn't try and present before the image has actually been acquired from the swap chain. So let's try adding in this semaphore. So we're going to need to create a semaphore. Next image sem. Create semaphore, I guess. That's going to need a device. Create info. We're not going to worry about allocation callbacks. Of course, if we're going to peek into a pointer, we have to allocate some memory. And we need this create info. New PK data. So, what goes in here? Right, so it's in the synchronization chapter. Semaphores, create semaphore, type next and flags. Flags must be 0, p next. Okay, there's no information to create a semaphore at the moment. And flags. this a bunch of times, so we got that all important do there. Semaphore creating void does not have field S type. Ah, we've forgotten to cast that pointer away. Cool, so we've got a semaphore. Now we need to signal that semaphore from acquire next image. Which one of these is it? Can also use a fence. Okay, it's that one. So yeah, Vulkan has semaphores, events, and fences. And it just depends on who is interested in being blocked. And in this case, we're interested in signaling from the GPU and being blocked in the GPU, which is exactly what a semaphore is for. So, what does that give us? Nope, we didn't check. This could throw an incorrect EK result, so let's just throw that in case it happens. I got this error again here. It's really unhappy that I'm presenting image without calling VK get physical device surface support KHR. And the semaphore must not be currently signalled or in a wait state. So that's kind of makes sense because we never emptied the semaphore, which we would have done here. So let's have present wait for that semaphore to be signalled before it does anything. Wait for one semaphore. Okay, what do we get now? Cool, it looks like it's just this problem of calling this VK get physical device surface support. What does the spec have to say about that? Not all physical devices will include, what is that, Windows system integration or something? Windows system integration support. Within a physical device, not all Q families will support presentation. We can determine this in a platform neutral manner by doing this query thing. And that needs a physical device, a Q family index, and a surface. So, physical device, Q family index, and surface. Oh, so, physical device, Q family index, surface. We're going to call Vulkan that mouthful. Physical device, view, family, index, surface, example. So basically this is going to write into a pointer. Which gives that all. How do we do this again? We just wrap it up in Vulkan VK pointer. Let's do something like that. Oh, that could also could go wrong, so we need to check that. Seems to be quite happy up to this point. Yeah, we're down to just one error now. Images passed to present must be in layout, VK image layout present source. Spec usage text states any given element must be its presentable image. How do you get into that? So yeah, there's this mention of like image layout transitions, which I don't really understand what that is yet, so sounds like we need to worry about that. VK image layout present source KHL must only be used for presenting a presentable image for a display. The swap change image must be transitioned to this layout and must be transitioned away from this layout after calling that. How do you transition? What does transition mean? Image subresources can be transitioned from one layout to another as part of a memory dependency. When a layout transition is specified in a memory dependency, it happens after the availability operation. Maybe this just means that we kind of really need to do a little bit more work here. So let's remind ourselves, record render pass simply calls command begin render pass. Let's also add finish render pass in here then. Might have to do the subpass stuff. Where's there? Begin render pass. Command end render pass. That's it's a command buffer. We haven't submitted that. Let's maybe try submitting that into our queue. Which is VKQ submit. Just going to inline this. For now. Got a queue. We're going to submit one thing. Oh no, actually. There's a bunch of stuff that's going to happen here, so let's put it down here. Okay, so we've got a bunch of stuff here. You know what, this really should wait on, this should be waiting on our image acquisition semaphore. It should also signal another semaphore, I think, possibly. We're just going to chain semaphores together essentially to get a dependency graph. we've got to do on a weight stage mask. I don't know what I'm meant to be waiting for. Maybe I'm not meant to be waiting here. Let's have a look at this tutorial. It waits for color attachment output bit. What does that do then? Okay. That basically says you shouldn't submit this command buffer to the queue until we're in this pipeline stage color attachment output bit phase, which means we can write to a color buffer, which makes sense. We are going to submit one command buffer They do signal render finished, so we're probably going to need to put that in. I'll leave it out for now. Come back to that. Parse error. I should be able to just do that. Semaphone. Let's see if it's happy with us submitting that render pass. Ooh, just lost the device. You must call VK begin command buffer before call to begin render pass. Yep, seems reasonable. I need to command buffer begin info now. Gonna go out on a limb and guess this goes here. Looks like it throws the result. I'm just looking at what's in my GHC ID at the moment. So what do we put in a command buffer begin info? Not much at all. Has flags, which must be these. I don't think I care about any of those, so hopefully we're okay with 0. And P inheritance info. Where's our render loop gone? Cool. What do you think of that? Presumably we have to finish a command buffer as well. And let's end command buffer. Chain out with throw VK result. We got tons of stuff here. So now, cannot submit command buffer using image subresource. Queue is waiting on a semaphore that has no way to be signalled. Wow, it's pretty cool it can pick that up. So apparently, every time we begin this command buffer, it's not in the right state. So I wonder if I meant to put this reset command buffer bit. Oh, okay, so I actually just do this once. That seems reasonable. But how though? I guess we don't have a frame buffer. Yeah, I guess in create command buffers. But what? So why do I need a frame buffer here then? I apparently needed it to begin the render pass. Oh, interesting. So they create a command buffer for each frame buffer. Now I don't actually need to pull the frame buffer out, I need to pull the command buffer out. Okay. Let's see, it'd be nice if I could find some information out about this thing. I mean, so one thing that is missing is when we do our render pass, we're not binding a pipeline. Doesn't look like they're doing sub passes here. They just begin a render pass, bind a pipeline, do a draw, end the render pass, and the command buffer. So maybe we need a pipeline. This stack overflow looks like it could be interesting. Not mentioned there. This could be in any of the shader stuff. So they do say the initial one is going to be undefined. What are we putting in ours then? This is when we create some color attachments, attachment descriptions. Ah, I put. That's not good. Better. Images passed to present must be in present source KHR. Yeah, I should be on that one as well. So we got these wrong. And this validation layer is an absolute lifesaver. That is looking pretty promising. So what's happening here is in our render loop, we are signaling next image sem in acquire next image, waiting for it in here, which resets the semaphore, but then we're also saying that we have to wait for it here, but that doesn't make any sense because it can't be signaled. So I imagine this command buffer should also write to the semaphore. So that can signal a semaphore. Now we're apparently out of validation errors. Maybe we've got some new ones. Or maybe this works. Okay, so we get this VK timeout again. So how are we meant to deal with that? Why is this not loading? We've got very slow internet today. Hopefully this stream's coming through okay. Yeah, it could be that. If you... I didn't actually check this. Let's try putting this queue wait idle. Not an efficient usage. Oh no, we've already got that. So they use a fence to do like a host block to wait for the previous frame's queue to have finished. Queue submit. Apparently it's something that's definitely worth reading here, which I just noticed is on the Vulkan docs wiki. Lots of synchronization examples. I'll have a read through that. Looks like I could definitely do with learning a bit more there. So let's see if we can work out what this timeout's about. It's definitely on the present. What's odd though is we also tried, here. Actually, you know what? I don't think it's. I think it's here. this is where we're hitting our timeout. Yeah. Not entirely sure what we're doing wrong here. No, they do max band there, so let's bump that guy up. I don't like the idea of just having this max band timeout. It seems a bit arbitrary, like surely I have enough of it. Oh my god, we've got a blue screen! That's amazing. So apparently we've got a memory leak because we're not using a fence. But I'm not sure I'm going to worry about that for now. Gonna redefine what blue is. Make sure that we can just potluck. Yep, you can't see that's on the wrong screen, but I can't get it to drag over. There we go. I've got this horrible teal colour, so that is working. I think we're going to wrap it up there for today. So we have finished recording our render path, we've submitted it. Oops. We've got a blue screen, finally. So that's the grand total of about 5.5 hours work and just shy of 1,200 lines of code just to get a blue screen. But there's a lot we can do to tidy this up, and I'm actually going to move on with that next, but in a future stream. So some ideas of things that we're missing. I mean, something that any Haskell will probably notice right off the bat over here is this begin-end paradigm screams that we should be using bracket or something along those lines probably, or at least a with type combinator. Might not necessarily be a bracket, but you know, having to remember to call end command buffer, there is clearly some kind of scope here, so let's introduce scoping operations. This right field stuff is horrible, and the Vulkan API library that we're using does have a DSL that could tidy this up, so I might have a look at that. I'm also wondering if we might benefit from using something like Rio or reader T over IO monad in general to tidy up the idea that a lot of these things like require some kind of context to operate. So for example, find key family index, this physical device could actually just be supplied as a reader T monad, we can start to build up a bigger reader environment for other operations, because we're only ever going to have one physical device, one logical device, one queue that we're using. So rather than having to pass all this stuff around, I think Rio or something might come in useful. What else I want to look at? Resource cleanup needs to happen as well. Might look at using the managed monad for that, which is basically like a CPS transform monad, so you can attach a kind of finalizer at the end. So we might plug that in, and I think we'll finish this last to do as well, which is work out how to correctly use Vulkan loader, because I've actually had to export a special LD library path just to get this application to work. So anyway, let's one last thing, get rid of some of this debug text and see if this can finally go through RenderDoc. Let's link all of this. Cool, so we've got our blue window back again. Fire up Q RenderDoc. That's a zero-to-quake-3. What? I don't understand. Maybe unhappy about the LD library thing. What about? Oh, what's going on over here? Wow, all sorts of stuff going on there. Don't know what that is. So we can capture, which takes path to an executable. Oh, that sucks. Looks like we're not going to be able to use RenderDoc on this executable. So it's not enabled, so I wonder if if we enable some extra extensions or something, we might be able to get that fixed. I don't know. Never mind. I was hoping we could get some insight with RenderDoc into what Vulkan's doing, because we're definitely going to need something like that later on. I'm using the integrated Intel graphics card on my laptop at the moment. It does have an NVIDIA card in there, so if I can ever work out how to get that damn thing to work, that might give us some better options to play with. Anyway, we'll wrap that up there. Cheers for joining me, everyone, and I think we'll probably be streaming again tomorrow around the same time, and we'll try and get a triangle on the screen. Well, we'll get through these to-do items, but if we can get through all of those, we'll try and get a triangle on the screen. So yeah, we are very close to actually doing some Quake 3 programming, which is pretty exciting. But yeah, thanks for joining me.